Already we have been discussed in the last video probability of events. If the two events are independent, the probability of E given E given F equal to P of E, probability of E. The probability of both E and F occurring, for example, this one E, this one F. So we are multiplying here. Actually, P intersection of F, P and P of E and F. P, sorry. It's on. How do you know? Very well. Okay. If the two events are mutually exclusive, the probability of either E or F. Mutually exclusive means same like that. So here addition P of E equal to P of F. P of union F. Here both, if the events are not mutually exclusive, you need to correct correct overlap. So here P of E U union F equal to P of E equal to, sorry, plus P of F minus P of E and F. P of E and F equal to P of E into P of that is probability F given E. Okay, next we will see Bayes theorem. Bayes theorem for any two events. P probability of A given B. This is the conditional probability equal to P and P probability of A and B divided by P probability of B equal to, here probability of B given A into probability of A divided by probability of B given A into P given A plus BV P of probability of B approximately given that is sorry, probability given B given A into P of A. Frequency list. There are two fixed parameters in a model, though they may be unknown at times. Fixed parameters in model, though they may be unknown at times. Okay. Data contains random errors. Data contains random errors which have a certain probability distribution. Gaussian, for example, mathematical routines analyzes Mathematical routine analyzes the probability of getting certain data given a particular model. Mathematical routines analyzes the probability of getting certain data given particular model. Bayesian. There are no true model parameters. Instead, all parameters are treated as random variables. Instead, all parameters are treated as random variables. Random variables like this. So, with the probability variables with the distributions, random errors in data have no probability. Random errors in data, random errors in no probability, no probability distribution, but rather the model parameters are random with their own distributions. Mathematical routines analyze the probability of a model given some data. The statistician makes a guess period distribution and then updates the guess with the data. The following points are basic definitions. We will see here. Types of data. There are two types of measurements, quantitative and categorical, nominal. This is discrete data have a finite values. Discrete data have finite values. Continuous data have an infinite number of steps. Infinite number of steps. Categorical nominal. The possible responses consists of a categories rather than numbers. That is measure amount of something on a continuous scale. Errors. Random error, systematic error. Due to chance with no particular pattern. No particular pattern, and it is assumed to cancel itself out over repeated measurements. Repeated measurements. Same repeated coming. No, and it is assumed to cancel itself out over repeated measurements. Okay. Systematic error as an observable pattern. As an observable pattern, and it is not due to chance, so it is causes can be often identified, and it is not due to chance, so its causes can be often identified. Reliability. How consistent or repeatable measurement are. How consistent or repeatable measurement are. Multiple occasions occasions. Reliability. Test, retest. Temporal. How similarly a test perform over repeated administration. Multiple forms. Reliability. Parallel forms. How similarly different versions of a test perform in measuring of same entity. Internal consistency, reliability. How well the items that make up instrument test reflect the same construct. Reflect the same construction. Okay. Validity. How well a test or rating scale measures what is supposed to measure. Content validity, concurrent validity, predictability. How well the process of measurement reflects the measurement content of the domain of interest. How will the process of measurement reflects how will the process of measurement reflects the important content of the domain interest? Concurrent validity. How will inferences drawn from the measurement from the inference the measurement can be used to predict some other behavior. Some other behavior, some other behavior is measured at approximately same time. Predictability, the ability to draw inferences inferences about some event in the future. Probability distributions, statistical inference, statistical inference relies on making assumptions about the way data is distributed, transforming data to make it fit some known distribution better. Statistical inference relies on making assumptions about the way data distributed, transforming data to make fit some known distribution better. A theoretical probability distribution. Theoretical probability distribution is defined by formula that specifies what values can be taken by data points within the distribution and how common each value or range will be. Population and samples. We rarely have access entire population users. Instead of rely on a subset of the population to use as a proxy for population. Same statistics estimate estimate unknown population parameters. Same estimate unknown population parameters. Ideally, you should select your sample random from the parent population. But in practice, this is be very difficult due to issue establishing truly random selection scheme, problems getting the selected user participate. Representativeness is more important than randomness. Non-probability sampling. Subject to sampling bias, conclusions are of limited usefulness in generalizing larger population. Volunteer samples. Convenience samples collect information in the early stage of a study. Quota sampling. The data collector is instructed to get a response from certain number of subjects. Certain number of subjects within classification. Probability sampling. Every member of population has no probability to be selected for the sample. The simplest type of simple random sampling, SRS, systematic sampling. Need a list of your populations. You decide the size of the sample and then compute the number n which dictates